Hello. Today we're going to be doing some tutorial help on prefix conversions. So the general rule I want you to think about here is that when you have equality, a big number should go with the unit that is small, and a small number should go with the big unit. And so oftentimes asking yourself, who's the big unit, who's the small unit, you can check that the numbers are essentially opposite to their size. Here's some examples. When we think of quarters and dollars, quarters is smaller than dollars, and so I expect the bigger number next to quarters. You can see that it's 4 quarters that's equivalent to $1. When we think of pennies and dollars, same thing. Pennies are smaller than dollars. I expect there to be more pennies. Pennies and quarters. Pennies are smaller than quarters. I also expect a larger number next to pennies. Okay, so let's consider prefixes. What do prefixes do? Prefixes modify what comes after it. So if you have just the prefix, it doesn't mean much. We need something that comes after it to determine what is going on. And so if you look at the prefixes here on this kind of right side, I'm going to point out that positive exponents makes whatever comes after it bigger. The modifier makes things bigger. So tera, giga, mega, and kilo makes something bigger, whatever comes after it. Negative exponents, however, makes things smaller. So whenever you have negative exponents, it shrinks whatever comes after it. So this would be this set here. So one of the things we can do is to find an equality easily is to substitute the definition of the prefix into its location on the equality. So here's an example. If I have kilogram, I can replace kilo with its definition. And so kilo means 10 to the third. And so I can take this definition of kilo and basically do a substitution. I take the kilo off and replace it with 10 to the third power. So 1 kilogram then is equivalent to 10 to the third, or 1,000 grams. We can also apply this with something, say, with mega. So let's find mega on my chart here. Mega is located right here. We can see that the definition here is 10 to the 6. So I can say mega is 10 to the 6 grams. Or in other words, 1 megagram is equivalent to 1 million grams. This also works. So what about small prefixes? It's very similar, but slightly different. So let's start with what we were doing before. We're going to replace centi with its meaning. So centi is 10 to the negative 2, and we're just going to go ahead and drop that in and replace and substitute the prefix of centi. So we can say that 1 centigram is 10 to the negative second power, or if we were to rewrite that, we can say that it's 1 over 100. When you have a negative exponent, it basically means 1 over. So 1 over 10 squared is 1 over 100. Okay? Now, I don't really like fractions in my equivalencies, and so what I typically do is I get rid of the fraction by multiplying 100 on both sides. So if I multiply the right side by 100, 100 divided by 100 essentially cancels out, and we multiply by 100 on the left side. What we get is something that looks like this. 100 centigrams is then equivalent to 1 gram. Now, very beginning of the video, we talked about how small units should have big numbers next to it. So if we look at this system here, centigram, centi makes things smaller. This would be the smaller unit. Smaller unit here has a bigger number next to it. And so here it's one way of checking that we have the correct relationship here. Or we can say that gram is the bigger unit, and this is a small number next to the big unit. So that looks good. So I don't like thinking about all those relationships, and so I've created a shortcut system that I'll call the big homie system. And the way it works is your goal is to figure out who is the big homie or who has the big units. Typically, all I do is I check the sign of the exponent for the prefix, and that tells me whether the prefix will make things bigger or make things smaller. The moment I know what the prefix does, then I can determine who big homie is. Okay, and I typically set a 1 next to big homie. Big units should have small numbers, and 1 is typically what I use as my small number. Now on the other side, I typically then use 10 to some power, and so I basically strip off the negatives and I just look at the exponential number, and that will tell me how many zeros should go after the 1. And so if it says 10 to the negative 2, I basically ignore the negative and I make it 100. 10 to the second power is 1 with 2 zeros after it. And so that's typically what goes on the other side that doesn't have the 1. So how do I use the big homie system when I set up conversion? Well, let's start by analyzing this problem here. Convert 3.2 megagrams to grams. I'm going to start by looking at the prefix here, which is capital M. You can see that capital M is mega, not lowercase m. So mega is 10 to the 6th power. You can see that the power is positive, and so this means that mega makes things bigger. I would then define megagram as essentially my big homie. And so when I set up this conversion factor, I'm basically going to start my t-chart like this. I'm going to go ahead and drop the identical unit on the bottom right, and put my target on top. So mega makes things bigger. That means that this guy here, right here, that's big homie. Big homie is because mega makes things bigger, so megagram should be bigger than gram. I put a 1 here. What I'm then going to do is I'm going to analyze the exponent here. The exponent is a 6. That means that I have 1 with 6 zeros on top. 10 to the 6th power is essentially 1 million. And so this is how I would set this problem up. Mega would cancel, and then I would get something where we have a multiplication here. Numbers on top get multiplied, and I'm going to carry that unit across, and so I get 3,200,000 grams. So this is how I would do number 1. Now, what does this look like for number 2 here? So let me clean this up a little bit. Let's go ahead and set up the second problem here. All right, so I want to convert 4.8 kilograms to grams. We can see that the prefix here is lowercase k. And so on this side, I'm going to look for a prefix with lowercase k, and that's kilo. Kilo is 10 to the 3rd power. And so to set this up, I would actually put 4.8 kilograms up here. We'll drop kilograms to the bottom, grams on top. Kilo makes things bigger. It's a positive exponent, so that's big homie. And 10 to the 3rd power is 1,000, or 1 with 3 zeros. That drops on top. Then I just get 4.8 times 1,000. And I get 4,800 grams. Okay, that doesn't look too bad. So what happens if I'm going to do the same system here, but I'm going to have prefixes that make things smaller? So let's analyze this in detail here. Let's start by setting up a t-chart. 8.4 mg, mg to g, and let's start by looking for lowercase m. Lowercase m is actually located down here on the bottom, and it stands for milli. Notice that the prefix here is 10 to the negative 3rd power. That negative exponent tells me that milli makes things smaller. And so milligram is a small unit. That means that gram without the milli is the big homie. So the big homie here takes the 1. Now, how many milligrams does it take to make up 1 gram? Well, milli is small. Small units should have big numbers next to it. What I do is I take a look at the definition here, and I ignore the negative, and I look only at that 3. And it tells me that it should be 10 to the 3rd power, or 1,000. It takes 1,000 little milligrams, little homies, to be equivalent to 1 big homie, which is 1 gram. Units would cancel here, and here the thousands on the bottom, and so I'm going to do division. 8.4 divided by 1,000, and I get an answer that looks like this: 0.0084 grams. Let's go ahead and try this again. We'll set up the same kind of thing. 1.2 nanograms. I'm going to change nanograms to grams, and I'm going to find lowercase n on my prefix chart here on the right. We can see that lowercase n means nano, and it's 10 to the negative 9. So we can see that the negative exponent makes this nanogram smaller than gram. Big homie then would be the gram. And what goes on the bottom is the number of zeros that matches the exponent of 9. And so that would be 9 zeros. Okay. Units cancel. And so what we have here is 1.2 divided by 1 with 9 zeros after it. And we get something like this, 1.2 times 10 to the negative 9 grams. All right, so we have some practice problems for you to work on. And so I'd like you basically to set up and solve each of these using what you've learned. And so the prefix chart is embedded on the right. And so all you need to do is set up some t-charts. So go ahead and try to do that, and pause the video now. And if you're trying to get the extra 5 points of extra credit, you would basically do this on a separate sheet of paper, and you would show me all of your t-charts and your solved answers. Okay, welcome back. I'm going to actually show you the final answer just to make sure you're on the right track. And so here are the answers. I have 3.89 times 10 to the negative 7, 52,880 millimeters, 1.84 times 10 to the 10th gram, and I have 0.198 kiloliters. I've even written one of them, A, for you to kind of give you an idea of what I expect to see. And so I expect to see that for B, C, and D. If you're having trouble, go back and rewatch the video and see if you can make this work for you. Okay, so the last thing I want to kind of talk about is what I call a prefix to prefix. And the easiest method to use is to convert to what I call the no prefix base unit. So if I'm looking at example 1 here, I want to convert 583 nanometers to decimeters. I don't want to do this all in one step. I could do it, but it's actually not as clean. So what I typically see is nanometers to meters with no prefix, and then to decimeters. This is a 2-step conversion, and so that's typically what I would do to kind of set that up. How would I set this up then? Well, let's set up a t-chart here, and all I'm going to do is I'm going to drop in 5.8 nanometers up here. I'd convert nanometers into meters. Then I'd convert meters into decimeters, and I do it stepwise in this fashion here. Okay, I'll let you figure out the numbers that go in here, but I expect the answer here to be pretty small. Okay, go ahead and pause the video and fill in the numbers here, and I'll check in once you're done. Okay, welcome back. We can see that nano makes things smaller. I expect the non-nano unit, the M, to have the 1, and then I expect something like 9 zeros on the bottom. Here, deci makes things smaller. I expect the 1 to be with the meter here, and deci is 10 to the negative 1. That leaves a 10 on top. So what kind of math do we get on the other side? Well, what goes on the other side then is 5.8 divided by 1 billion times 10. Notice the 10's on top, so we're going to multiply, and we're going to get something that looks like 5.8 times 10 to the negative 8 power. And the units here is decimeters. We're going to do the same thing on the bottom. We're going to set up a double prefix thing, and so we're going to change megagrams into grams. Then we'll change grams into centigrams. Go ahead and fill in the numbers down in here. Go ahead and pause now and fill the numbers in. Okay, welcome back. We can see that mega makes things bigger. We expect the 1 to go with the mega. We expect 6 zeros on the other side. Centi makes things smaller, so the 1's going to go with the other side. Centi is 10 to the negative 2, so that's 2. So here we have 34 times a million times 100. And answer here would be 3.4 times 10 to the 9th power centigrams. Okay, so if everything is working well, this is your second set of practice problems, and go ahead and pause the video now and set up these double t-charts. And so remember to go from the prefix to the base unit with no prefix, and then go to the second prefix. Use the chart on the right, set it up. Okay. All right, welcome back. Here are the answers. All the answers are published here. Obviously, I expect you to show me your double T charts if you want credit, but you can go ahead and kind of check your work to see if you're on the same track. All right, that's it, and I hope this was instructional and useful for you. Peace out.